All right. So distributing, taking the outside number, multiplying it by each term inside the parentheses. Let's see. Table 4. What would be the first answer after distributing? Like that. So taking the outside term, multiplying it by each term inside. I hope that you guys know when terms start and end. If not, I'll try to highlight it for you. And I'm not really counting the one outside the parentheses because it's already separated by the parentheses. But inside the parentheses, I have two terms. So I have this 3a and this positive 7. Notice how I'm keeping the sign that's in front of each term with that terms, because it will make a difference when you're multiplying. Like if it's a positive, I'm a positive, I should get a positive. But yeah, so class, what is a times 3a? 3a squared. So let's adjust that first term to be 3a squared. And then we're multiplying a by 7. So class, what's a times 7? 7a. Over a little bit. Yeah. And make it a 7a. And now it is correctly distributed. Questions on that? All right, so then the next one, table 5. What is the answer for after distributing? What's the simplest form for this? Okay. Right, go ahead. But yeah, so class, let's take a look at that one. Inside the parentheses, I have 3 terms. So here's my first one. Here's my second one. And here's my third one. All right. So then I'm taking my outside term, multiplying it by each term separately. The numbers you multiply like normal. So like this one, the number in front is technically 1. So -2 times 1 is -2. Let me put that more in the middle so it doesn't look like negative. All right, and then class is m times m squared, m cubed. It is. And the rule when we're multiplying variables is we're just adding the exponents. And if the exponent's not written, it's a 1. So that's the 1 plus 2 gives us 3 for the new exponent. So that is correct so far. Now multiply by the 6m. So class is -2 times 6, -12. And is m times m squared. Good so far. Now the last term. -2 times -1, is that a +2? And then there was no m in this term to multiply it by, but that doesn't mean like that there's not going to be an m in my answer. It's still there, I just don't have another variable to multiply. So that is correct, good. Table 6, for the last bullet point, what would our distributed answer be? Minus 8x divided by 1. All right, so let's see that one. And again, I'll highlight the different terms for you. Hopefully that's starting to be easier to see. So I have 2 terms in the parentheses. First one is a positive times a positive, so that should give me a positive. No coefficient other than 1, so like this word is 4. And yeah, x cubed times x squared is x to the fifth. We add those when we're multiplying the variables. I don't have another y in this first term to multiply it by, but I had one originally from here, so it should still be there. So that looks good. Now multiplying it by the second term, 4 times -2 plus, what is that, -8? And then no x to multiply it by, but I should still have like x cubed there. And y times y is y squared, so that is correct. So really in this unit, because this unit is quadratics, really you'll only go as high as something squared. But we're practicing factoring by GCF today, so that's why we have like polynomial expressions that might be higher than quadratic. Looking at our answers, which, if any of these, would be considered a quadratic? So say like this is bullet point number 1, 2, and 3. Show me with your fingers which one you think is quadratic. Okay. All right, so good. You guys got it right. Earlier today, I saw a lot of 2s. So I think they were just used to seeing a trinomial and seeing that that's quadratic. Really, out of these 3 examples, only the first one would be considered quadratic because there's a variable squared and nothing higher than that. So that first one is an example of something that would be quadratic. This one right here has something cubed, so that is what makes it not quadratic, and there's something higher than something squared there. This one's actually called cubic, although you don't really need to know that this year. And then this is just like a polynomial expression. This is a bunch of things put together, but only the first one would be considered quadratic based on how it looks. But yeah, today we're going to be factoring by GCF. We did a little bit with that last week when we did the Kahoot on your testing day. So you've kind of already done it a little bit, but today you'll have some notes with some steps that you can memorize and follow. And really, anytime we're being asked to factor, our first step should be to check for GCF. So we're finally going to make sure we really understand that, so that we can continue on with the unit. So for what is factoring, that's going to be separating expressions back into its factors. I'm going to put back into a product, back into a multiplication problem, where you can see what we multiplied by. So what will be given on your notes and your homework today will be what kind of looks like our answers from the warm-up. And we're going to be asked to give the factored form. So like the simplest form, we'll just use like the first bullet point as an example. The simplest form can't be multiplied out. It's already reduced, already combined like terms. The factor form would be where you could see what we multiplied. So the factor form would be like what we were given originally in the one. All right, and we're going to go over the steps. They're typed out for you. And we've also talked about the steps before, but now you'll have them typed out and you'll have them for your notes. This is your note sheet. The one that has like all the examples and all the definitions is your note sheet. This is the one that I want to see on binder check day. The other paper you picked up is your practice, the one that's single-sided and that says evens or odds. There's always a lot of confusion on binder check day for which one I want. On binder check day, I only want to see the note sheets. For your practice, you would have already turned in and uploaded, already gotten points for that. This, I'll check on binder check day. So let me just go through the learning targets real quick. So we're factoring by GCF today. You need to be able to identify the GCF of an expression when there's numbers and variables involved. You need to be able to divide each term by the GCF. And think about it like this is opposite of distributing. In distributing, what do we normally do? Make sure we're paying attention. In distributing, what do we normally do? What do we do in the warm-up? You multiply when you distribute. If factoring is the opposite of distributing, what's the opposite of multiplying? So that's why we're gonna divide each term by the. In my opinion, I think the only hard part is identifying the GCF. And then you're just dividing, and then you can check your answers by distributing. So I'm recording right now. I always update the video recording every year, but the math is the same as it's always been. So you can check the videos that I also link here in case you're working ahead. Like I said, you have a practice on paper today, just evens or odds. And there is no way you can do all of them in your head. No way. So I need to see some work shown. Maybe there's a couple of them you can do in your head. But if you don't have work shown on any of them, you're just gonna get a 0. You need to show work. So I will check them tomorrow. So try to have it done by tomorrow when you walk in. I'll come around with my clipboard while you take notes tomorrow. But if you are not gonna be here or you don't get full points tomorrow, you can upload it to Schoology until the deadline. Okay, so there's that. Your next assessment is not for a while, because this week your big assessment was yesterday. What else? Next week you don't even have a assessment either. It's the Monday after that you have your next quiz. So additionally, you could like look ahead. We're not testing for Unit 7 until May. And that May 8th is actually like the third to last week of school. So you have a good amount of time, but grades will change a lot around like the third week of school. So let me just show you something. Hold on. We currently are here. So we're in April 9th. And let's see. We're in April 9th. We have like a few more lessons. You'll have already learned everything you need to know for units 7 by the 25th. So by the end of this month, you'll have already learned everything you need to be successful on the unit test. The unit test is not until May 8th though. So like there's this whole week of project/assessment points that could also really impact your grade. I'm hoping it'll just boost your grade, but you know, if you decide to really just let yourself go as far as grades, really stop caring and just thinking that you're okay because your grade has been solid for the past few months, I'm telling you, in the third to last week of school, you have 150 assessment points going in, and the week before that, you have like at least 50 project points going in as well, maybe even more than that. So you can really make or break your year in just a couple of weeks. I could have put the unit test up here, make it a little earlier, but then to me that I just don't see a point in doing that because after you retake it, there's nothing more you could do anyway. So I'd rather you have like the practice to clarify any understanding, to give you a little more time to come to tutoring and ask questions and then assess you. Because after you retake it, there's nothing more you can do. It's not like you could retake it again. It's not like you could come correct it more after that. So like you need to make sure this next unit test is also good because you can go from a C to an F really quickly. Anyway, you can also see after we retake it, that same week, a few days after, you have your first final exam. And then the week after, you have your last final exam. So it's going to go by quick.
I'm giving you as much time to understand Unit 7 as possible. You need to make sure that you're staying locked in for the rest of the semester, or it'll change very fast. And I'm recording this right now, so don't say you weren't warned. There's a lot that we still have to do, but you won't really see it until the last few weeks of school. Okay, anyway, moving on. That's my speech for you to keep you successful the rest of the semester. We're going to go back to this. All right, so a few more blanks to fill in. If something cannot be factored, what do we call it? Prime. So think like 1 is a prime number because it's just 1 times itself. 2 is a prime number. 3 is also prime. 4 is not because, that could be other factors other than 1 in itself. So if it's not factorable, it's prime. Now, we're going to show you how to identify a GCF. If there's no GCF between the numbers or the variables, then that answer is prime. I shouldn't see more than maybe like 1 or 2 answers on your practice that say prime. Because sometimes we tell students like, yeah, if it's not factorable, it's prime. And then I just see it all over your paper and it's like very rarely prime. Okay, so just keep that in mind. So here's the steps. They're typed out for you. Try to understand them. Pay attention. First step in factoring by GCF is to look at the coefficients. What's a coefficient? The numbers that are in front of the variables. They can also be constants too. So because constants technically are not in front of variables, but like the 3 and the 7, those are what we're looking at first. We're looking at the numbers, checking for GCF, looking for them. If there is one, we're going to kind of like write it off to the side, and then we're going to look at the variables. If a variable is present in all of the terms, we can factor it out. If not, then we can't. So it has to be present in each term, and if it is, you need to take the one with the smallest exponent. So your GCF can never be bigger than the smallest amount you have. Then you are doing the opposite of multiplying. You're dividing each term by the GCF and putting the remaining factors in the parentheses. Your GCF on the outside. Lastly, you can check your work by distributing. All right, so it's all typed out for you. If you get stuck, follow these steps. We're going to go right into an example. So let's look at number 3 together. All right, so look at the numbers first. 8 and 36, find the GCF between those. Again, it can never be bigger than the smallest amount you have. So check to see if your smaller number is the GCF. Does 8 divide evenly into both 8 and 36? It doesn't. If you do 36 divided by 8, it's a decimal. So it still can't be bigger than 8. So start like breaking down 8 into its factors and try to start with the bigger ones. So like we already ruled out 8. Check to see, is 4 divisible into both 8 and 36? So that's going to be part of my GCF. 2 is also divisible, but that wouldn't be my greatest common factor. The G stands for greatest. We want the bigger one. It's hard. Now check the variables. Do they both have an M? Do they both have an N? So then you can't factor out any variables. My GCF is just 4. It's going to live outside the parentheses. And inside the parentheses is what we get from dividing each term by the GCF. So table 8, what is 8M divided by 4? 2M, good. And table 9, what's 36N divided by 4? Is that all? Okay, good. So at this step, once you've divided it, at least like mentally check, like if I were to distribute, would I get my original problem? And I would. That's how I know I did it right. But the numbers you divide like normal, 8 divided by 4 is 2, 36 divided by 4 is 9. There's no variable to divide it by. It still shouldn't like magically disappear. So m divided by 1 is m, n divided by 1 is n. Good on that? Okay. I'm gonna have you guys try 2 and 4 then. And then we'll go over those in about a minute or so. Go ahead, Reagan. All right, table 1, is there a GCF between 7 and 7? If so, what is it? Okay, thank you, Tristan. Yes, it is 7. So they're the same number. In that case, the GCF is just that number. And really, there's only 2 factors for 7, 1 and 7. The greatest one is 7, right? So 7 is part of my GCF. Table 1, can I factor out any variables in this one? Do I have a y present in each term? So then I can't. So your GCF should just be the 7. And that should be outside your parentheses. Inside should be what you get from dividing each term by 7. And usually at this stage, I'll try to see if there's anything that will cancel. Because if you have the same thing on top and bottom of a fraction, what does it cancel out to? 1. So, like, I'll just kind of glance. There was nothing here that canceled out, so that's why I didn't do it here. But here, like, this first 7 over 7 cancels. So does this one. So my first term ends up just being y. And what does my second term end up being? And it's a -1, because there is still a minus sign. All right, but if you have the same thing on top and bottom of a fraction, it cancels out to a 1. And if like there's nothing else in that term, then it's just a 1. Don't like put blank or don't put a 0. It's still that. And if I were to distribute, I would get my original. Good on that? So then table 2, is there a GCF between 5 and 30? Yes. What is it? 5. Can never be bigger than your smallest number, so check. Is my smaller number divisible into both 5 and 30? Yes, it is. Table 3, can I factor out any variables? No, because they both don't have an X and they both don't have a Y. So my GCF is just the 5, that will be outside the parentheses. Inside is what we get from dividing each term by the GCF. So the first one, the 5's cancel. I'm just left with an X. And then in the second term, table 4, what's 30y divided by 5? What makes your vowel, what's 30y divided by 5? 6y. And then check, at least mentally, if I were to distribute, would I get the original? And I will. All right. We're going to go to the back now, where we can actually see some variables being factored out. So yeah, we're not doing every single problem on the notes. I don't expect you to go back and do every single problem, but you could if you wanted to like check the online notes after. But you know, do. On the back, let's look at number 10. Together. All right, so we have a 16 and a 24. can never be bigger than your smallest number, so is 16 divisible into both of these numbers? No, 16 into 24 would be a decimal, so no. So then break 16 down into its factors and try to start with like the greater ones. We just rolled out 16, but here's all the factors of 16. Again, we ruled this one out already. Is 8 divisible into both 16 and 24? So then that's my GCF. 4 is also divisible, but it's not the greatest. 2 is also divisible, but again, not the greatest. So that's why we kind of start from the greatest down. Now check the variables. Do they both have a B? And whenever it is present in each term, you take the one with the smallest exponent. Right now, they both have the same exponent, so there's b to the first power. Do they both have a c? Yes. Which one has the smaller exponent, c squared or c to the first power? So then this is going to be my GCF. You can never take more than the smallest amount you have. And then inside the parentheses is what we get from dividing each term by the GCF. And usually at this step, I'll try to cancel out anything I can. So like in the first term, the b cancels because they're the exact same. They're both b to the first power. In the second term, the b and the c cancels because again, they're the exact same. Now it's less that I have to divide. So class with 16 divided by 8, c squared divided by c. Through the visual, if that helps, c squared divided by c gives me, good. And then now 24 divided by 8. And that's it, because I already canceled out the b and the c in that one. So that is my factored form of that one. And again, you could distribute, you could check it, but this is the answer. Later in other lessons, like actually probably tomorrow, we're gonna factor out a GCF and then look at the parentheses and see if they can be factored out anymore. But today we're not doing, we're just doing GCF today. All right, ready to try one or do you want to see one more? I didn't get that. One more, okay. Let's look at a 3 term. So scrolling down, let's look at 15. So when it's a 3 term, it's not much different. It's just now you have to find a GCF that works for all 3 terms. So between 2, 2, and 4, what's the GCF? 2, good. Never be bigger than your smallest number. 2 is divisible into 2, 2, and 4. Yes. Does each term have an x? What's the smallest exponent on the x? So I can only factor out an x to the first power. Do they each have a y? Yes. What's the smallest exponent on the y? So this will be my GCF. Once you've identified it, divide each term by the GCF. I think it's easier if you can cancel out anything at this step so that it's less to divide, but you can only cancel it out if it's the exact same. So like this 2 over 2 cancels, the x's don't, y's cancel. These 2 over 2's cancel, but remember there's a negative there. The x's cancel in this one. Over here, the x and the y cancels. Now we're just dividing this one. What's x squared divided by x? Good, just x. There's a minus here. And what's y squared divided by y? And lastly, what's 4 divided by 2? That's that. Let's see, I'll write it down over here. That way you can still see that. I want you to try number 9. And number 14. I'll probably project those answers, so do have them attempted. And then maybe share with the partner at your group. And then at the end, it'll just be comparing if you got it completely right, or like in the experiments. So 9 and 14, I asked you to try, and I have them projected on the screen here. So starting with 9, if you did it completely right, your GCF should have been 15AB. Should be on the outside of your parentheses. And inside you get A minus 2 after dividing by the GCF. So you can kind of see over here what canceled out. In the first one, the 15s and the B canceled. A squared divided by A is A. In the second term, the A and the B canceled because they were the exact same exponent. So then it cancels. Negative 30 divided by 15 is negative 2. Questions on that? Okay. So then 14 was the other one I asked you to try. That answer over here, if you did it completely right, the GCF would have been 6ABC squared. And my, in parentheses, should be 3A minus 8C. So then in the first term, you can see what canceled. The B and the C squared canceled. In the second term, only the A and the B canceled. And just divide the rest. By the way, like I showed you a visual earlier, and I think that visual really helps you understand why it's that way. So like for example, C cubed divided by C squared. This is C cubed. This is C squared. It ends up just being C. But really, like the exponent rule says that you can just subtract the exponents on the same base. So 3 minus 2 is 1. Okay. But luckily in quadratics, like it won't be that high usually that you have to worry about. But that's how you do it. Also the GCF being 6, like you can see over here me writing out my factors of 18, and I started eliminating the greater ones until I found the one that they have in common. That's the greatest, right? GCF is what it stands for. Questions on that? Okay. So I did a trinomial earlier. I haven't had you guys try a trinomial yourself yet. So I just want you to try 17 now as your last one to try together, and we'll go over that one in a couple minutes. When and if you finish early, work on your practice, the evens or odds, and make sure you're working on the practice. If tomorrow you show me the note sheet, like you're not going to get credit for the practice because those are two different things. Questions on what I'm asking you for? So try 17 and then work on your practice until we go over 17. Camila will add try number 17. A trinomial, only difference here is now you just have to make sure it actually works for all the terms. So starting with the numbers, the 6, 14, and 10. GCF can never be bigger than your smaller number. So does 6 divide evenly into all 3 numbers? It doesn't. So that doesn't even divide evenly into one of them. So it needs to divide evenly into all of them. And so 6 can't be the GCF. Off to the side, I'll like write out the factors of 6, which is just these 4 numbers. We already eliminated 6 as an option. And start eliminating by like the greater ones. So is 6, 14, and 10 all divisible by 3? Are they all divisible by 2? So then that's my GCF. Now look at the variables. Is there a y present in each term? What is the smallest exponent on the y that you see? So y squared is going to be part of the GCF. Not just y. It's the one smallest exponent you have, and that's y squared. So then you can see me dividing each term now by the GCF. I'm going to check to see if there's anything I can cancel, and really the only thing are these y squareds in the last term, nothing else cancels. So now divide the rest. Class with 6 divided by 2. What's y to the 4th divided by y squared? Good, so you can just subtract the exponents when it's like that, set up as a division problem for the variables, you subtract the exponents. Class with 14 divided by 2. And y cubed divided by y squared. And again, 3 minus 2 is 1, that's why it's y to the first power. And lastly, what's negative 10 divided by 2? And negative 5. So make sure the signs look just like this. We separate our terms with plus and minus signs. And that's our answer for the last few. All right, so again, make sure you're working on the practice. It's the one that's single-sided, just evens or odds. Make sure you show words. I'll have the key up. I don't have it right now, but I'll have the key up eventually on the wall where you can check your answers and make sure you're practicing this the right way. Question?